The intermediate value theorem says that if you have a continuous function f on a closed interval, and you choose some number n between f of a and f of b, the value of the function at the endpoints of the interval, then you can find a number c within the interval ab where f of c is equal to n. So that's a lot of stuff, but it's trying to illustrate a simple idea, which I'll draw on this graph. So we'll say that my starting point a for the interval is here. And b, the endpoint of the interval, I'll say it's over here. So there's a and b. So next, I'm going to define the function f at both a and b. So why don't we say that this is f of a. And then over here, we'll say that this is f of b, where the y values start and stop. Since the function is continuous, you can draw a graph that goes from this point to this point that has no breaks, holes, or vertical asymptotes. And if you do that, the graph could look like anything, but I'll say the graph looks like this. So it's like increasing, maybe it drops down a little bit and then goes back up, but eventually it ends up right here. So I just drew some continuous function f. So that is f is continuous. Because it's continuous, you get every single y value between f of a and f of b. Nothing is missed. And that's where this number n comes into play. So if I put a number n, let's say it's right here on the y-axis, you can find a number c in the interval from a to b where f of c is equal to n. And that's all this theorem is trying to state. Between f of a and f of b, any number you choose will have a solution that we can call c that lies within the interval ab. One important application of this theorem is proving the existence of a root. And so for this graph that I drew, does f have a root in the interval from a to b? And root is, it's some number x naught, I'll call it, where the graph is equal to 0. Does this exist? And the answer is, yeah. The reason is the number 0 falls between f of a and f of b, so that's right here. This is y is equal to 0, so that's acting as my value n. And there is definitely a spot where the function equals 0. It's right here. I'll call that x naught. So by the intermediate value theorem, we have a continuous function on a closed interval. The number 0 falls between f of a and f of b, and that's enough to conclude the existence of this thing. So the answer is yes, there is a root. I don't know what it is, but that doesn't matter. The point is, does one at least exist? And that's what we can use this theorem to do. In example 1, let's use the intermediate value theorem to explain why this function must have a real root somewhere on the x-axis. And again, just a reminder, to say that x naught is a root means there's some number that when you plug it into the function, you get 0 back for the y value. Now, we're not even given an interval to work with here, so it's going to be our job to find some interval ab where perhaps, let's say, f of a is negative and f of b is positive. If this happens, that means, 0 has to be between f of a and f of b. And if this is continuous, that's enough to say that there is a real root just by using this theorem here. So step 1 is like, okay, well, what interval could we work with? I want to choose a number a where this function is negative, maybe a number b where this function is positive. So by examining the function, I think a good choice of a would be 0. I know if you put 0 into this function, the only thing that's left over is -1. So in this case, f of 0 is equal to -1. I now want to find some value b where this function is going to be positive. So b will be bigger than a, and hopefully if I put it into this function, we'll get a positive number back. It might take a little bit of effort to find it. For example, you could think of using 1, but if you put 1 into this function, you get a negative number. You could think, maybe I'll try 2. I think 2 will also be negative, because if you put a 2 here, you get 16. This is going to be minus 8 times 3. Like, that's not looking good. But maybe the number 3 works. So let's see. If you look at f of 3, that's going to be 3 to the 4th minus 3 times 3 cubed plus 3 minus 1. So f of 3 is, okay, 3 to the 4th is 9 squared. That's 81. Oh, well, we get another 3 to the 4th. That's also 81. We then get plus 3 minus 1. And so f of 3 is 2. That is positive. We also need to know, okay, is this thing continuous? And the answer is yes, because it's a polynomial. Okay, so let's state the conclusion. I'll say, by the intermediate value theorem, since f is continuous on the interval from 0 to 3, and since f of 0, which was equal to negative 1, is less than 0, is less than 2, which was equal to f of 3, there exists an x naught in the interval from 0 to 3 such that the value of the function at this number is equal to this value, 0. This means, yes, there is a root to this equation. And the work we did was we had to know this was a continuous function. It is. We found a number that made this function negative, another that made it positive. And since 0 is between a negative and a positive number, this function has a real root.